I introduce Saint Cecilia.
That was awesome.
Our starship journey from our lunar sister city, Orbis Noctum, was epic.
You're right, but I'm glad to be back on Earth. It was fascinating to finally see the carbon dioxide transportation and offloading process in person.
I know. It was great to see our engineering counterparts on the moon to see how they're utilizing the carbon dioxide we produce from our mitigation strategies here on Earth.
Good afternoon, ladies. Welcome back to the island of Modus Maris. I remember my first trip to the moon. Seeing the final step in the life cycle of our captured carbon dioxide really showed me how our processes are vital to life in both locations. Now that you're back, we can go over our presentation one last time to be sure we didn't miss anything.
Let's do it. I always love sharing our accomplishments with incoming engineering freshmen at Modus Maris University. The technological advances developed here will certainly get them excited about engineering.
I'll start. Good afternoon, everyone. My name is Sadie Eberly. I'm a mechanical engineer who manages the city's rotating and fixed equipment reliability programs. Since this is your first week back on the island, I would like to get you up to speed with life here in the city. As you know, Modus Maris is the most advanced man-made floating structure in the world, consisting of 100 spar platforms connected through rigid causeways and tethered to the ocean floor. Located 200 miles off the west coast of Costa Rica in the Pacific Ocean, Modus Maris began in 2022 with a goal of testing the adaptation that a floating city would reduce the impact of ocean level rise. Now in 21-23, Modus Maris is the most advanced man-made floating structure in the world.
Hello, my name is Marco Vigo, Process Engineering Director for our global network of carbon capture systems. The city is based on transit-oriented development with mixed use of high rises built above and below the platforms, offering a blend of residential, commercial, business, entertainment, and educational spaces to make the city living convenient for our diverse populations of citizens and visitors. The submarine high-rises provide exceptional views of the ocean with the added benefit of increasing buoyancy and lateral stability to the platform network. Everything you need is within a 10-minute commute of your dorms. Rooftop parks are connected by skyway bridges where residents and visitors can enjoy the great outdoors.
What's up, guys? I'm Kennedy Lapizinski, Materials Engineering Head at Modus Maris University. For commuting, an e-bike share program is provided. You can use the Modus Maris Transit Authority app to call an electrical VTOL shuttle to reach your destination. Zip pods connect adjacent buildings, while a subsea high-speed transit system called the Downingtown provides travel to the mainland. Vertical agriculture towers throughout our city produce fresh produce and livestock, and fresh fish is abundant.
As you can imagine, maintaining a floating city is labor-intensive. Corrosion engineers monitor the impressed currents and sacrificial cathodic protection systems, and a team of coating inspectors assure that any coating damage is identified and repaired. Keeping water out of our underwater living spaces is a constant battle, so remote operated vehicles investigate leaks and repairs are performed by our dive teams. Cha-ching.
Over 100 years ago, Earth was experiencing an exponential increase in greenhouse gases following the Industrial Revolution. Climate pattern changes resulted in rising sea level, increased storm intensity, and food chain disruptions. Climate scientists identified that the burning of fossil fuels accounted for 67% of human-induced greenhouse gas emissions. Following the engineering design process, a multinational team of engineers and scientists identified the problem, brainstormed the solution, and designed, tested, and repeated this process until they developed a mitigation strategy they called CURE.
Cure.
Capture atmospheric carbon dioxide.
Utilize the carbon dioxide by converting it into products.
Reduce fossil fuel usage by developing efficient renewable energy sources.
And electrify transportation by revolutionizing infrastructure and storage.
The capture team uses two carbon capture methods, one natural and one man-made. Our natural method supercharges the world's largest carbon dioxide sink, the ocean. Piston-driven pumps powered by wave buoys pull nutrient-rich water from the deep ocean and discharges at the surface. Phytoplankton and giant kelp flourish and absorb carbon dioxide. Marine life feeds on the phytoplankton, while the utilized team harvests the kelp as the main feedstock in our bioplastic manufacturing.
Our man-made method started with our material engineers developing a carbon dioxide absorbing metal organic framework they called Motosorb. Chemical engineers use the Motosorb in our cager process, carbon dioxide absorbing, geothermal generating, eliminating, and repurposing system. Fin-fan exchangers coated in the Motosorb extract carbon dioxide from the air. Once the Motosorb becomes saturated, Condensate from our geothermal power plant flows to the exchangers. At 180 degrees, the carbon dioxide is released, collected, compressed, and stored.
Chemical engineers from the Utilize team developed a method to convert carbon dioxide into methane for use in Methalox rocket engines via a low-temperature process using cerium oxide nanoparticles in the presence of a ruthenium catalyst and an electric field. This carbon-negative rocket fuel is used to export our motor-absorbed carbon dioxide to our lunar sister city, Orbis Noctum, where it is used in their greenhouses and can produce additional rocket fuel. Electrical engineers from the Reduce team outfitted each SPAR platform with wave energy converters. Waves constantly raise and lower a magnetic sleeve over a stationary generating coil to produce electricity.
Material engineers from the Electrify team worked with civil engineers to design an inductive charging grid that is embedded into road and walkway surfaces to charge vehicles as they drive, just like wireless phone charging. As you can see, our CURE strategy has resulted in a major decrease in atmospheric carbon dioxide.
We are excited that you have chosen to study our methods and hopefully one day improve them. Direct air capture and ocean augmentation have been proven techniques to reduce the carbon dioxide in the atmosphere.
These mitigation techniques, together with the development of abundant renewable energy sources, have reduced our fossil fuel usage to further reduce greenhouse gas emissions. We have proven that the ocean can nourish, protect, and reverse humankind's impact on our planet.
Thanks to the hard work by so many brilliant minds, we live in a carbon negative world. It is fitting that modus maris is Latin for the movement of the sea, so always remember, the motion of the ocean has set us carbon free.
Well, folks, that was great. So my question is, how did the engineering design process help you create and develop your future city?
Well, with the engineering design process, it got our city and our engineers thinking on how we would reduce climate change in our world. So with our city, we tried to reduce the impact of ocean level rise, since ocean level rise is what happens when climate change. With the engineering design process, we tried our best to make the best solution to reduce the carbon dioxide in the atmosphere.
Through this, they use the CURE process. CURE stands for capture atmospheric carbon dioxide, reduce that atmospheric carbon dioxide, utilize that carbon dioxide, and electrify our transportation. Under C for our CURE method, we have two carbon capture methods. One is natural and one is man-made. Through our natural method, we take nutrients from the deep ocean and we pull them up to the surface. At the surface, our giant kelp pulls in those nutrients and absorbs that carbon dioxide. Then we use that giant kelp that we have harvested as the main feedstock in our bioplastic manufacturing.
With our man-made method, we use the CAGR process, which is carbon dioxide absorbing, geothermal generating, eliminating, and repurposing system. With our CAGR process, we have a carbon dioxide absorbing metal organic framework, which is called Motosorb. With that Motosorb, it extracts the carbon dioxide from the air so that no carbon dioxide is in the air. And after our carbon dioxide gets extracted, we use that carbon dioxide and we send it up to our lunar sister city on the moon, Orbis Noctum.
The way we convert that carbon dioxide into fuel is that we take a percentage of that motor-absorbed carbon dioxide. We save the rest for later. We take that carbon dioxide and we put it in the presence of a ruthenium catalyst and electric field with cerium oxide nanoparticles. This will then convert the CO2 into methane. We then use that methane as fuel for our Methalox rocket engines. Then we take the rest of the carbon dioxide, put it in the rocket, and we ship it off to our lunar colony, Orbis Noctum, where it is used in their greenhouses to produce oxygen. This process can also produce additional rocket fuel.
Thank you. The next question is, did any of your team's initial goals evolve as you work on your project?
No, we set our goals and I feel that we've accomplished them well. Our first goal was to make sure that we had one adaptation and one mitigation, and then we were able to accomplish that. Another one was that we were to come up with a second adaptation and second mitigation strategy, and we were able to fulfill that. We wanted to make sure that we had a diverse population as one of our third goals, and we were able to do that.
Our fourth goal was also to make sure that we got everything done in time and that everything was perfect with our city. We wanted to make sure that the adaptations flows with the categories that we wanted to show with our city and how we reduce the climate change impact.
What factors did you consider while laying out the zones in your city? Are these zones separate or are they mixed use?
So our residential and commercial are mixed use. In our high-rise buildings, we have residential and commercial retail in our high-rise buildings. Our industrial zone is separate from our residential and commercial zone, so that with residential, we do not bother the citizens of our community with the industrial noises.
Every platform contains mixed-use high-rises. Mixed use meaning they have alternate purposes. Every platform has residential, commercial, business, entertainment, and educational spaces, so that the living space is convenient for our diverse population.
In these spars, we made sure that it was accessible to everyone, whether you had a disability, whether you may have been not able to walk as well. Each transit-oriented development has an elevator for you to be able to get to your location that you want to. We have skywalks, which are able to connect you from each spar if you want to be able to make a quick commute. And we also have the piezoelectric things to help piezoelectric walkways to be able to help you walk around the city and charge our city at the same time.
Okay. The last one is a little long, so bear with me. What innovative and futuristic technologies is your city using in the production of its power, and how has this reduced or eliminated carbon emission?
So I think our most innovative technology would be our rescue bots. Along with our rescue bots, we have drones. So each of our platforms has a fire and a police station. The red is fire and blue is police. When commuting, a rescue bot is on each platform. So if you were to have an accident, your rescue bot would take you to the nearest urgent care, which is in each transit-oriented development. If you can't receive the care that you need there, rescue bots will take you over to our main hospital. There you can receive the care that you need.
With power, we take geothermal energy. With our geothermal energy, that is pretty much our main power source, and it's also the main power source we use to extract the carbon dioxide from the air. We also use our wave energy converters, which with the motion of the waves will take energy and they'll send it up to our electricity grid. We have our piezoelectric walkways that if you are driving and you have an electric car, it'll charge your car as you drive. And when you are walking, it'll charge the city as well.
Another piece of advanced technology that our city has is the methane process, converting carbon dioxide into fuel, as I've explained before. This, as it does put methane back into the atmosphere, it is only a fraction of what we originally removed from the atmosphere. And thus, this is also a good thing, meaning we can continue to take out carbon dioxide and methane from the atmosphere to continue using our process.
So I understand where your city is located. So I have a two-part question. First is real quick. What country are you associated with? And then the second thing is, what do your citizens do for fun?
Well, our city isn't really connected with any country. It is basically, we take a lot of our resources and our ideas to be accessible to everyone from everywhere. We don't really associate with any country at all. If we do associate with any country, it would be Costa Rica, being that we use our Dynatube to transport people and goods to Costa Rica or from Costa Rica so that people can get to our city and leave our city as well.
We encourage our citizens to go out for a run on the piezoelectric walkways. That way they can generate electricity for our city. However, unfortunately, this doesn't generate anything major, but it does generate things like streetlights.
For fun, most of our citizens like to be able to go scuba diving under our city and be able to watch the marine life as it unfold underneath their city. They also love to do jet skiing around for our city. A lot of people find that fun, find it as a new athletic term.
Our next team is from Downingtown Middle School, and the timer will start when they start speaking.
Cerulean Lodo is such a beautiful place for me to live. Just 80 kilometers north of Cairo, Egypt, you'll find the greenest, cleanest city out there. I appreciate what our city has to offer, but I want to learn more about life back when Cerulean Lodo was overtaken by climate change. Gosh, I wish there were people who could teach me.
We are engineers here to grant your wish.
She scared me. I was hoping for something more like fairy godmothers to grant my wish, but engineers will have to do. Don't get me wrong, I love everything about Cerulean. The commercial zone we can shop with my mom and dad anytime we want, the residential zone where my beautiful home is, the industrial zone where all the buildings are carbon free, and especially the cleanest air my little lungs have ever breathed. But grandma's always going on about how it's easy, and back in my day, Cairo, climate change, dirty air.
Oh, you dear sweet child. Don't you want a pony or something?
No, I want to learn more.
Here, take these super special engineer glasses that allow you to be as smart as us. Now get ready, Nyla, because boy, would I have a story for you. It was 100 years ago, and Cairo was the dirtiest I've seen it. The air was polluted, and the water was undrinkable.
The city was plagued by extensive climate change problems, like frequent sandstorms, flash floods, desertification, coastal erosion, rising sea levels. But the worst of all was the air we breathe.
You guys are engineer fairies. Why do you care?
Why do we care? Why do we care? The 21 million people living in Cairo had to breathe the second highest levels of particulate matter under 10 micrometers in diameter, and the highest levels of particulate matter under 2.5 micrometers.
With every breath, citizens became more susceptible to minor medical conditions like wheezing and asthma, and even more severe diseases such as lung cancer and even death.
Was there not a proper healthcare system like Cerulean care? No Cerulean circlet? No genetic analysis? No biometric hologram? What happened to the climate change problems?
I'll tell you what happened. Engineers around the world recognized that solving Cairo's climate change problems could help solve other cities' climate change problems. With a deep breath and a little engineering design process magic, Cerulean Lodo was born.
And that breath you took was cleaned by none other than APVI.
APVI, the flying vacuum thingies that patrol the city filtering and cleaning air?
Yes, those thingies are called Aerial Pollution Ventilation Interface, or APVI. It's our city's adaptation strategy for air pollution.
Drone-like technology extracts polluted air and filters it, releasing clean air back to the environment and capturing the pollutants.
Ooh, and inside the APVI, there's an accessible DAC filter, which uses potassium hydroxide to create chemical bonds with the CO2. You know, an additional layer of filtration along with the microscopic carbon nanotube membrane.
Oh, what? I didn't know those glasses actually worked.
Anyways, after going through a pellet reactor and being crystallized, the molecules are then heated, causing them to separate back into carbon dioxide and potassium hydroxide.
The carbon dioxide is stored, then transported underground via geological sequestration, while the potassium hydroxide is reused to capture more carbon.
APVI is released from strategic ports throughout the city and draws in air through its 4 rotors.
Not to name any names or anything, but software engineers like me developed an onboard scanner that detects the most heavily polluted carbon-filled areas.
As I was saying, this gives APVI the ability to clean 13.1 cubic kilometers annually.
Engineers, always gloating. Thanks to APVI, Cerulean Lodo enjoys decreased levels of air pollution, as well as decreased health risks, including ischemic heart disease, which was once responsible for 32% of air pollution-related deaths.
But APVI doesn't come without its trade-offs. Electrical engineers who specialize in energy generation and storage considered that while APVI generates more energy than it consumes, it has nowhere to store the excess energy.
As a compromise and a means to prevent overheating and malfunctioning, APVI only pours for a maximum of 11 consecutive hours.
Actually, 12.
Did I pick every little thing I do?
I'm an engineer. What did you expect? A pocket protector?
Anyways, APVI can also be used as our intra-city public transportation called Floto.
And Lodomotive is our inner city public transportation, which utilizes superconducting magnets to lift and propel trains at very high speeds.
Correct.
But APVI is not the only technology working to adapt to air pollution. Building bonder is a sealant made of partially synthetic chlorophyll derived from native flora and starch-based polymers. The sealant is painted onto the buildings in all 3 zones. It absorbs carbon while preventing the weathering from sandstorms.
The air isn't the only thing of the city that needs to be cleaned, though. Engineers also design carbon nanotube reverse osmosis adaptable nozzles to clean water.
Try and say that 5 times fast.
Or CROAN for short, are tubes of carbon nanofilters which are used to solve saltwater permeation.
Through reverse osmosis.
CROAN and carbon nanofilters are installed in household nozzles and pipelines throughout the city.
Ooh, and in the morning on my way to school, Lodo learn, the sunrise reflects on the glass. Oh, so beautiful. My dad was talking about how
The glass from the residential buildings is made from the sand collected by Sandbot?
sandbot. Way to cut me off. Sandbots are the flying drones that collect sand from sandstorms and converts the wind's kinetic energy into electricity, which we use as our city's supplemental energy source. But where does the city get its primary source of energy? Burning dirty fossil fuels? Power of friendship?
Our city's primary source of energy comes from our air pollution mitigation strategy, the Wanium hybrid generator system.
The Wanium hybrid generator system has 2 components, Wanium solar panels and Thang generators.
The first prong of the system is Thang generators, which use compression to create electricity when force is applied to piezoelectric material.
While the second prong, Wanium solar panels, utilize the Seebeck effect and absorbs heat to create thermal electricity. When the electrons move from the warmer side of the material to the cooler side, it creates an electrical current.
The panels also use photovoltaic technology to create positive and negative charges, which also create electricity.
In order for the Seebeck effect to occur, the materials in the solar panels need to have a low thermal conductivity and a high electrical conductivity.
The materials used were chosen for having a low ZT value to transmit the negative charges, and the positive charges were transmitted using a different material with a high ZT value.
Wanium solar panels use aerographene in lieu of glass at the top layer of the panels to help best absorb photons.
Aerographene is made of aerogel and graphene, making the panels stronger, clearer, and lighter compared to panels from 2022. This results in decreasing thermal conductivity and making the panels more efficient.
However, a trade-off solar engineers who specialize in solar efficiency considered that the generators have a low efficiency, with both materials averaging between 25 to 57% respectively. However, we compromised this to use layered low efficient materials to maximize the efficiency yield.
Solar engineer?
Yep.
So much engineering, so many problems to solve. Everyone must have fairy engineering godparents.
Actually, we engineers don't use magic. We use the engineering design process. First, we identified the problem.
Like climate change and not having a clean city?
More specifically, air pollution in Cairo. Next, we learn the specifications.
Like how to quantify the problem constraints present?
Yep, next we brainstorm solutions.
Like APBI and the Wanium hybrid generator system?
Then we design it. We build our solutions.
Then we test it, improve it, redesign.
And share.
Okay, Nyla. I think it's past your bedtime. Sweet engineering dreams.
That was very good presentation. Nice. How did the engineering design process help you create and develop your future city?
So one of the movable parts we have is the carbon nanotube reverse osmosis adaptable nozzles, CROAN. It's to represent the solution CROAN, which is used to solve saltwater permeation. So originally we wanted to do a sliding mechanism where we could show off the process and visual aid for it. And we just didn't know how to do that. And we came up with a few ideas and some of them didn't work. So we had to go back to the drawing board. And then our mentor showed us some old cabinet parts, and that's how we built the sliding mechanism for this.
In addition to using the engineering design process for all of our different moving parts, we also had to use it when we were developing our solutions and finding ways to continuously improve and continue designing our solutions that we already had, like APBI and the Wanium hybrid generator system. We had to use the engineering design process to find trade-offs and find compromises that we could make for those trade-offs.
On top of the solutions and the movable parts, just as a team in general, we had to use the engineering design process because at first our communication wasn't the best. Sometimes we wouldn't talk to each other about what we wanted to help get done that day or what needed to be done in the weeks to come. But over time, we got better at this, and now we are a well-oiled machine.
Did any of your team's initial goals evolve as you worked on the project?
Yeah, so I don't think we actually we have our Wanium hybrid generator system movable apart, and there's like a lot of components to it. The lights were coded by a team member using an Arduino, and there are dowel rods powered by motor. It was just a lot of hard work, and I feel like we didn't think that we could get it all done, but coming to the competition with it is really a big goal for us, and we're really proud of it.
Another way that we developed our solutions and changed our original plan was when we were designing this lotus flower, which is where the APVIs are stored. We eventually ended up using a vegetable steamer to make it and cutting out the flowers individually. But at first we were trying to cut out the entire thing individually and glue it all together and find ways to make it open then, which we were having a lot of trouble with, and we had to continuously find new materials and new ways to make the blue lotus flower.
And with the drawer component of our carbon nanotube reverse osmosis adaptable nozzles, or CROAN, at first the drawer didn't run terribly smoothly. It didn't want to open efficiently. And we also had to string the lights into the tubing, which was quite hard for our team members, but we did overcome it, and we have this here today.
What factors did you consider while laying out the zones in your city? Are the zones separate or mixed use?
So we have 3 zones in our city: residential, commercial, and industrial, and they're all interconnected for the accessibility of our citizens.
We wanted to make sure all 3 zones were accessible for every one of our citizens. So for example, a person could live in a residential building, but work in an industrial building and shop in a commercial building. And we wanted to make sure that the residents of our city had access to all 3 of those zones. So we interconnected all 3 of our zones and made them accessible for all of our cities, and they can especially be accessed through our different forms of transportation.
In our 3 zones, we have 3 different wealth levels so that there's something for everybody everywhere, and they don't have to work harder to get what everyone else deserves in Cerulean.
What innovative and futuristic technologies is your city using in the production of its power? And how has this reduced or eliminated carbon emissions?
So for our Wanium hybrid generator system, is actually our primary source of energy in our city. So we have our part of the Wanium hybrid generator system, which uses triboelectric energy and piezoelectric energy that is also lined in our pedestrian walkway LOTO linked to create energy. And then there are the Wanium solar panels, which uses chemical bonds and photons and a heat flux to also create energy. So these 2 work interconnected to create our primary source of energy in our city.
Using the 2 different prongs, the thing generators and the Wanium solar panels, we were able to generate electricity from both compression and static electricity when compression is applied, and generate electricity from heat and light in the city to make it a very efficient and effective source of energy for our citizens.
Back in Cairo in 2022, their form of energy released a lot of greenhouse gas emissions. So with this cleaner form of energy, we are limiting those emissions and not having any produced into the air. So we are getting rid of air pollution.
It's working. I remember you saying that you take the CO2, you separate them out and then pump it into the groundwater. Is that right?
Yes. So our solution, APVI, has an accessible DAC filter, accessible direct air capture. So the filter is created of potassium hydroxide, and the carbon that it captures is then sent into the ground using a process called geological sequestration.
When the carbon is captured, we use potassium hydroxide and we create chemical bonds with it. And doing this, we're able to crystallize the carbon. And after a couple steps of heating and cooling and different chemical bonds, we're able to, again, separate the carbon dioxide and the potassium hydroxide, but the carbon dioxide in a crystallized form, which we're able to store underground safely through geological sequestration.
Now that it's stored underground, it is out of the air, which creates less air pollution for the citizens of Cerulean, allowing for them to have a greener, cleaner community.
So what do the people in your city do for fun?
So we have a lot of different activities to do in our city. For example, we have our recreational area with our Cerulia Aries, which is a library, is a modern day library that has an expansive book collection. And this building right here is a jazz club for our citizens to go and have fun in.
We have a lot of different options for our citizens. One example is our recreational Center City Park here, which is accessible and open to all of our citizens, and it provides a lot of activities in it. And it is a great place for exercise and for fun with our citizens. And we also in these parks have virtual reality systems, which allow the people in the park to be able to play a large variety of sports and enjoy themselves while in the park.
Since our city has a lot of engineers and engineering opportunities, after a day of hard work, you might want somewhere fun to be. If you're on your feet all day, maybe you want to go to our art studio. You can sit down, you can do paint, or maybe you have been sitting all day. Maybe you just want to stretch your legs. You can come here to our yoga place where you can do all sorts of types of yoga, and there's so many fun things for people to do here.
Q&A is over. So now we have St. Andrew, Newtown.
Hello, Dr. Bubbleworth. Welcome to New Hygeia. I'm Mary Kate. We are looking forward to showcasing our beautiful city in the hopes that you will invest in it. What brings you here?
Tragically, my hometown sunk under 2 feet of water due to rising sea levels, so I'm in a market for a new home.
I'm sorry to hear about your city. We were threatened with a similar issue in the former borough of Manhattan in New York City, but we put in some adaptations to help mitigate the problem. Perhaps our lead engineer, Bob Jordan, could explain.
100 years ago, in 2022, the increased rising temperatures caused sea levels to rise to dangerous levels, which had, and New York City being along the coast, was affected by this. This is why we became New Hygeia.
Hygeia, that's a very interesting name. Where did you get that?
Hygeia was the Greek goddess of cleanliness, and that was part of our goal, to have a clean city with a reduced carbon footprint to help stop climate change. Our motto is protecting our citizens and their environment.
Our engineers started by building surge barriers and seawalls along the coast.
Wait, won't that lead to an increase in erosion and loss of habitat?
That was a concern. So that's why our engineers built mangrove forests along the coast, which helped, also cut down erosion and are great habitat for animals.
I'm glad to hear that. Do you have any other recreational areas for your citizens?
We certainly do. Here's a scale model of our city to show our ways of incorporating green space.
As you can see, we have green on all of our buildings. These green that not only provide food for us, but they keep us cool in the summer and warm in the winter.
Yes, vertical farms provide fruit and vegetables, which are part of our citizens' healthy diets. Green roofs help regulate temperatures and are a natural habitat for wildlife.
That's great. Do you have any other buildings, especially for the disabled and elderly?
Yes, all of our buildings are elevated to account for future rises in sea level, and entrances to the buildings are designed for access to disabled and elderly.
That's great news. Do you have any, excuse me. Is there any transport systems in your city?
Yes, we have many. We have, for one, right here, we have our tram system. And underneath here, we have our innovative Hyperloop system. Our Hyperloop goes around 700 miles per hour and travels with vacuum-like tubes to reduce the need for energy.
Our Hyperloop is powered by our microgrids. Our microgrids also power the rest of the city. So if one part of the city loses power, then they can easily be powered by another area. This increases our power resiliency. The microgrids are mainly powered by nuclear fusion, but can also be powered by geothermal, solar, wind, and tidal power.
Wait, couldn't nuclear fusion lead to waste or worse meltdowns?
That was a concern. So that's why back in the 2030s, our engineers also built the tokamak. The tokamak fuses 2 hydrogen atoms to a helium one. This boils water to move turbines.
Yes, the tokamak was a significant technological advance. It took our engineers many years to design it, using the design thinking process.
My final concern is your healthcare technology in the city. Can you tell me more about it?
Yes, we have affordable healthcare for all of our citizens and vaccines for all illnesses. Healthcare is very important for everyone to have. Cancer and other illnesses are performed using our biometric smartwatches, which detect cancer and other illness threats in the earliest stages so they can be treated early.
Also, we have our air conditioning and heaters also protect us from our homes from bacteria and fungus that grow.
You have me convinced, but are there any other trade-offs for this technology?
One major trade-off was our reduced dependency on jobs. As we mentioned before, some of our food is grown right here at home, and each home 3D prints many materials.
But we try to provide our citizens with careers in educational, medical, financial, and even tourism.
All
Well,
right.
you have me convinced. My family and I will be moving to New Hygeia as soon as possible.
And New Hygeia and its 1.5 million citizens look forward to your investment in our future.
Thank you, Dr. Bubworth.
So how did the engineering design process help you create and develop your future city?
It helped us because we learned how to make it with bottles. It helped us build the city we both first of all we thought about what we were going to build, and then we built it together we looked at buildings. We looked at like possible shapes for the buildings, and then we put multiple pieces together, like maybe we use some spice boxes or water bottles to put together.
How did any of your team's initial goals evolve as you worked on your project?
Well, some of our initial challenge was to prevent rising sea levels. And then we thought of seawalls, but it ended up involving into adding the mangrove forest, which added a good decoration to our city.
What factors did you consider while laying out the zones in your city? And are the zones separate or mixed use?
All of our zones are mixed together. We wanted our residential and our industrial areas to be mixed so that it was easier for our citizens to move around the city. So we have our houses next to some of our working areas so that people don't necessarily always have to take the train. Sometimes they can just walk to work.
What innovative and futuristic technologies in your city in the production of, what innovative and futuristic technologies is your city using in the production of its power, and how has this reduced or eliminated carbon emission?
Okay, so as we mentioned before, we have the tokamak. The tokamak fuses 2 hydrogen atoms to a helium one, and it boils water to move turbines, and that is underneath the ground, and it does not emit carbon at all. Or even if there was a meltdown, the nuclear waste wouldn't spread all over the place. So, and also our buildings are powered by microgrids. So if one part of our city goes out of power, then not the whole thing.
So your power source is hydrogen fusion,
Yes.
and you have only one? Or do you have many units like that?
We have one big one, and then we have the power fuses to the microgrids which power the whole city.
But we also use wind power here, which powers our tram, so that that's one of our means of transportation. We also use geothermal energy to warm our mangrove forests because mangroves survive in warm climates. So they are able to thrive here, even in the cold climate.
Oh, that's neat.
Thank you.
So tell me a little bit about the governance of your city. Who's in charge? Who runs the city? How do you make laws? Who makes the laws? Things like that.
Well, we're a democracy. We have a mayor who is elected by the people. We have multiple political parties, so there's not only 2. And we encourage all of our citizens to participate in their government. So if they have concerns or questions, they can go to their representatives, go to meetings, and try to get their concerns addressed.
So how expensive is that watch?
The watch is actually free. We give it to all of our citizens that decide to move into our city. So like at the lobby, every building has like every place that people stay and live, every apartment, they have like big boxes of them that they just hand out to people and explain.
And we're able to afford this because the tokamak generates more energy than we need. So we sell it to local communities that surround our city in order to pay for these watches to keep our citizens healthy.
So when you were working on this project, did you and perhaps the rest of your team, did you have like disagreements on different things? And if you did, how did you resolve them?
Well, we had plenty of disagreements because we are a group of 30. So that's a lot of ideas trying to form one city. But we ended it with voting on the city name and voting on some designs, as well as having art teams evaluate which would look the best. And for the design, for the moving parts, we had a special team for that who would also decide what would fit best in our city.
So what do you do for fun?
We have lots of recreational areas for our citizens. In the middle, we have a big park. We also have our mangrove areas, which are recreational spots where people can play sports or hang out with friends. But a lot of our city is green. All of our houses have green roofs. There's a lot of areas outside for people to enjoy.
Also, we have our sports stadiums over here. So we have the football stadium and we have a basketball court. So we can also transform these into like different fields, like the basketball or the hockey rink, the basketball or the baseball fields or the hockey rink.
Does your city have a particular industry that you really focus on? Or is it a whole variety of different things?
The city really has a variety of different industries. Most of our industrial capability is placed underground in the repurposed subway system, but also we have a big tourism industry because it inhabits Manhattan, and it also is a very beautiful city that many people want to visit.
You said you're going to use geothermal energy. Where are you going to get it?
So we're gonna get it, like we have the it spins around really fast. That's how we attract the hydrogen atoms and the helium atoms.
So in Philadelphia, there's like 9 people running for mayor, at least 9 Democrats. And one of the questions they're going to all have to face sooner or later is taxes. What are you going to do about taxes? And that revolves around how do you fund and finance all the things that your city does?
Well, our city, as we talked about, brings in a lot of money from selling energy from our tourism industry. So we are able to have our citizens not have very high taxes because we bring in a lot of money, but all of our citizens have affordable housing and they all are able to have jobs because everyone is given an education. So the small amount of taxes that they do have to pay, they're able to afford.
All right. Whoa. All right. Sorry, guys. Haven't actually needed to use that because I got kind of loud and I usually don't use the mic. So everybody having fun? Cool. Me too, obviously. Next up, we have Lionville Middle School. And I was going to say, if you guys want to grab your mics from the judges and give me 2 seconds to step back behind the curtain, and when you start speaking, then I will start the timer and you have 7 minutes. And then we'll stop and it'll go over to the judges for 8 minutes. And I might be your MC for a little bit. I'm not really sure yet, so have fun.
Whoa, it's a clownfish.
Look at this cool model.
Did that clownfish just talk? That's not the point. What are you doing here?
Well, my coral reef was bleached and now I have nowhere to go.
That's the future of all life if climate change took over Kiara as well.
Wait, where am I?
You're in Kiara.
Kiara?
Kiara!
No, I've heard of Kiara. Kiara's amazing.
Wait, how do you know about Kiara?
Because I keep up with the current news.
Then you know that we prioritize the safety and health of our citizens, and that could include you too.
Tell me more.
Okay, deriving from the Aboriginal roots of Kia, a beautiful place, and Nanyara, made well again. Kiara means a beautiful place made well again, and it lives up to its name. The citizens of Queensland, Australia created this beautiful city. Look at the beautiful mountains, coast, and climate. Not just that. Kiara has a program where augmented reality glasses allow students to explore different career fields and connect to real-world scenarios.
Hey, my school didn't offer this.
We're talking about two different types of schools. Anyways, healthcare is accessible to everyone through watches powered by body heat and movement to monitor multiple health concerns. This way, as citizens, we immediately know when there's a health concern and can easily seek care from Kiara's many doctors and hospitals.
Guess how I get to the hospitals? In a clamambulance.
You're hilarious.
Well, I am a clownfish. Anyways, Kiarans don't travel by water like I do. They travel by air using air. It's called aerotrains. These autonomous trains levitate along a magnetized air-powered path.
Along with piezoelectric walking biking paths, Kiara citizens can move throughout the city zones. Industrial to commercial to residential to
Residential, like my anemone?
Yeah, our homes are made with aerogel insulated silicone material, making them both energy and heat efficient. It keeps us safe, just like your anemone. And the precise arrangement of the infrastructure helps accommodate the aerotrain system. But what truly makes this city revolutionary is how it overcame a seemingly unsolvable issue, climate change. A major impact was extreme heat, and it was devastating on Northern Australia. Floods, droughts, wildfires.
Don't forget the coral reefs. That was my home.
And it still will be in Kiara. Coral bleaching was when the warming water caused by extreme heat forced the coral to expel the vital algae zooxanthellae. When there's an absence of this in their tissue, as you can see, the coral turns completely white.
Yup, that definitely impacted me before.
But not in Kiara. We solve problems like this and so many more. Our coral is alive and thriving. Wait, that reminds me, East. That's the adaptation that keeps Kiara protected from so many problems like flooding, droughts, food and water shortages, air pollution, water pollution, wildfires, and even the sea level rise. Environmental assisted sustenance tech.
All of that in one system? I'm hooked.
Yeah, well, the first part of East is RAB, or a rapid aqua barrier. The flood sensors across the bay signal the valve to open proportionally to the water level. RAB's entire system is omniphobic, which means absolutely nothing sticks to it, not even aquatic life.
That's a real lifesaver for fish like me, or else we'd be in a real sea pickle.
Right. It's lined with wave energy converters to power the system. When the valve opens, the microscopic grate behind it allows only water to pass through. To avoid extra waste getting stuck, a separate filter sends debris up to the towers through a pipe. The clean water then goes through membrane distillation. But the membrane wall only lets water vapor pass through, leaving the salt and bacteria behind. The salt goes through our brine repurposing system, and the bacteria goes up to the towers. The nutrient water then splits between the storage tank and the towers.
These towers are CARE, or Kiara's Agricultural Reserve Environments. It uses the nutrient water and debris from RAB, along with additional resources from CARE drones to help provide food for the people of Kiara.
I see how this correlates to agriculture.
Ha ha, you're almost as funny as me. Anyways, CARE drones spread around the city and regulate the humidity of the air. They also use titanium dioxide coatings to capture nitrous oxides from the air and turn them into nitrate salts, which is used as a fertilizer. And they're powered by micro wind turbines while they're in the air.
So thanks to East, we have a technology that adapts to so many problems with just one system. Wait. Don't forget Kiara's solution to climate change. Right. The mitigation was crucial to combating climate change and its effects at the source.
The source?
Greenhouse gases, the root of climate change. To combat climate change, we need to eliminate greenhouse gases, which means we cannot keep producing them. For clean energy, Kiara uses a resource which comes in abundant amounts. Phytoplankton through PEC, or phytoplankton energy conversion.
Whoa, that reminds me. I forgot to have breakfast today.
Yeah, well, phytoplankton isn't only part of your diet. It's also the source of Kiara's energy. Phytobots disperse and collect the phytoplankton in the ocean to make sure the levels, which are monitored by marine biologists, are healthy.
To reduce the environmental change caused by capturing phytoplankton, Kiara's farms harvest these in enclosed facilities. And the cultivated phytoplankton is transformed to clean energy
by manipulating the photosynthesis process. Kiara's engineers harness chemical energy present in the photosynthesis process by infusing the system with electrodes and electron mediators. This yields biophotoelectrochemical cells. A mouthful, but this combination of electrolytes and semiconductors can turn chemical energy into electrical power. The quantity collected and harvested is more than enough to power Kiara daily.
So the mitigation puts Kiara on an unlimited energy source to help power the citizens' lives. Oh my God, it's official. Kiara is fantastic.
Yeah, it is fantastic, but nothing is perfect.
Oh, I know. With membrane distillation comes brine disposal, which is a risk since it's harmful if led into the ocean. So Kiara's scientists transform brine into sodium hydroxide and hydrochloric acid to help maintain the system, prevent contamination, and serve as a benefit. Relying on phytoplankton as Kiara's main energy source runs risks and benefits, making it a trade-off. Phytoplankton is a clean and unlimited energy source, but can be vulnerable to diseases as a natural organism and affect Kiara's energy output. All of these innovations are thanks to Kiara's many engineers and scientists.
Whoa, you do know a lot about Kiara. So, civil engineers designed Kiara's infrastructure, and transportation engineers create and zone our aerotrain system.
Chemical engineers created the membrane distillation and wrap, and marine microbiologists are crucial to the execution of PEC.
Using the engineering design process, they first recognized the problem, extreme heat, analyzed possible ways to combat this problem, tested out the major systems at first to ensure they were functional, and finally implemented these systems to ensure Kiara's bright future. It's getting late, and I need to go find my anemone before dinner.
All right, let's wrap this up. Our world is 4.5 billion years old. If all this time was condensed into the span of one day, then humans have been here for 3 seconds.
In a mere 3 seconds, humans have managed to destroy the foundation of this world by causing climate change. I know that from personal experience.
But using our reliable adaptation and mitigation, citizens are always healthy and safe. In the end, Kiara is a representation of making it to that 4th second.
Come on, you're gonna love your new home.
Wow. Oh. Share that.
Okay. That was fun to watch.
Thank
It was
you.
good jokes, yeah. So how did the engineering design process help you create and develop your future city?
So we use the engineering design process heavily in developing all the different systems in our city, such as our adaptation and mitigation system. So first, we would all separate into individual groups and research deeper into our climate change impact, which was extreme heat, and specifically how we could develop an adaptation or mitigation strategy with this. And we would each brainstorm one solution, and in a class of 26 people, that means we would have 26 different solutions to be able to select from and use. Then we would present these to the class, and we would be able to select a few, maybe like 5 or 7, to be able to research even deeper and continually redesign and refine these to make sure that we ended up with the best mitigation and adaptation strategies for our city.
Did any of your team's initial goals evolve as you worked on your project?
So our goals were set using our project plan, which set many initial deadlines for us, such as first draft of the essay, certain deadlines we had to meet for the model. But as we progressed throughout completing all of these aspects, we recognized that we had to be flexible with these timelines and potentially change and evolve our goals to accommodate to this as we approach the Future Cities competition. For example, when our essay deadline didn't seem like it was about to be met, either people had to come in or help, or we would have to recognize that we would have to change that deadline and put more work into the essay and put maybe the model's progression on hold.
So what factors did you consider while laying out the zones in your city? Are these zones mixed use or separate?
So we had to factor in many different factors, but starting with our zones, we have our agricultural and industrial, which is mostly green and silver. Then we have our commercial and residential that are mixed throughout. Our commercial is blue and our residential is white. And as you can see, they are in mixed use zones to make this, because we wanted to make sure that our residents had the utmost of access to commercial areas to make sure they had all the necessities they need. We also took in the factor that agriculture and industrial buildings would be best to be next to each other. So we took that in factor as well.
Along with that, we had to consider our transportation mode, our aerotrain systems, and look at ways to best accommodate that, as well as in factors such as taking our industrial and agricultural together because they have shared imports and exports, and then using the aerotrain system to accommodate that, as well as making sure the commercial areas and the residential areas are close together so residents have easy access to necessities of life.
What innovative and futuristic technologies is your city using in the production of its power? And how has this reduced or eliminated carbon emissions?
So for our city's energy source, we use phytoplankton through our mitigation system, phytoplankton energy conversion. Firstly, our phytobots go out into the ocean and collect a certain amount of phytoplankton, which we then bring back to our facilities, harvest them, and grow them until we use them for our energy production by infusing the system with electrodes and electron mediators, yielding biophotoelectrochemical cells, which can essentially be used to take chemical energy, turn it into electrical power to power the entirety of our city. Along with that, as a secondary power source, we also have piezoelectric walking and biking paths.
So these paths all around our city function as a secondary transportation mode to our main aerotrain transportation. However, they allow our citizens to be healthy while transporting around the city, mainly in in-zone areas. And they also allow us to create a secondary backup energy source. If, for example, any of the PEC centers were to happen to have something catastrophic happen to them, we would be able to supply this with backup energy.
A third energy source is within our adaptation, rapid aqua barrier. So part of this is lined with wave energy converters, which takes the potential and kinetic energy of the ocean to transform it into electrical power. This is not only used to power the system, but is also used as a secondary energy source for our city.
So how far are these zones? Do we need to use those, can we go from one zone to another by bike or?
Yeah, so our paths, not only they're represented on the model inside the zones, but we have paths running all throughout our city, as you can see with these bridges. So our citizens are able to have choices of their transportation. If they would like to travel on the air trains through zones, they are able to do that. But we also provide options for people who want to use our piezoelectric walking and biking paths to travel around the city.
So what do your citizens do for fun?
So citizens have a wide variety of activities, such as our city is surrounded by water, so citizens engage in multiple water sports. They can simply go scuba diving or snorkeling to visit our beautiful underwater ecosystems, or take a scenic walk on our piezoelectric walking and biking paths, and enjoy many more activities such as hiking, biking, and many more.
Along with that, Kiara's natural ecosystem and topography fostered a bunch of activities, especially in our tourism industry, such as hiking and biking along its beautiful mountain, spending a day in its multitude of coasts and beaches, as well as taking a scenic path on our piezoelectric walking and biking, as well as engaging in many sports such as cricket, rugby, and surfing.
So you're going to use phytoplanktons, and my experience with that is they stink when you take it out. Do you have a process to make sure that the city doesn't smell bad?
So on our PEC facilities, they are not in close contact with any of our direct buildings or any people, because they are harvested within these PEC facilities. So they're in a contained environment, one which can help in reducing factors such as smell, but as well ensures that our phytoplankton cannot be influenced by external factors, and make sure Kiara always has a sufficient amount of energy to power the city.
Additionally, we also don't keep all of the excess phytoplankton that these farms generate. So our farms produce more than enough phytoplankton needed to create power for our city. So we also help adjust the phytoplankton levels in the ocean, which not only helps climate change in our city, but also helps it globally, as phytoplankton can help absorb carbon dioxide, reducing ocean acidification, protecting coral reefs and many other marine life in all around the world.
Tell me a little bit about the governance of your city. Who's in charge? Who runs the city? Who makes the laws? Things like that.
So our government is a democratic republic, which means our citizens elect representatives to represent them in the greater government of Australia. And this makes sure that our citizens are able to advocate for themselves and have any problems in our communities be solved by these representatives. Our government also works a lot with our engineers and scientists to make sure that there's laws protecting our adaptation mitigation strategies and protecting our climate and city as a whole to make sure that climate change does not have any adverse effects on the city.
All right, next up, we have Queen of Angels Regional Catholic School.
Welcome to Lufuka in the Kingdom of Tonga. We trust that your trip was exciting, especially the underwater bullet train ride from New Zealand.
We are excited to share with you our world-leading carbon capture technology and how it has allowed Lufuka to thrive in spite of sea level rise.
We are confident that your nations will benefit from our climate change, adaptation, and mitigation strategies.
First, let's start with a tour of our city. Located in the South Pacific with warm ocean waters, lush vegetation, and beautiful beaches, Lufuka's population of 40,000 enjoys a relaxed lifestyle. Fishing, tourism, and agriculture are our leading industries, along with our advanced climate change mitigation industries such as biobrick production. Tourists and residents enjoy our underwater park system, designed by marine biologists and civil engineers.
80% of Lufuka's population lives along the coast in floating hydro houses built on a buoyant substrate. By code, all structures within 200 meters of the coast must be built on these substrates to resist floods and rising tides.
Lufuka has a multi-level transportation system, or MTS. The underwater bullet trains, using supercavitation, can travel at 300 kilometers per hour. While a walkable city, on land, we also use smart cars to get around. Our airspace is reserved for the autonomous E-Quick Speed, response vehicles that provide immediate emergency services to all citizens.
Lufuka uses 100% renewable energy. Geothermal energy is produced using heat extracted from a nearby volcano and transmitted via superconducting cables. Hydroelectric energy is produced from tidal turbines, while all other structures use solar cells to produce on-the-spot energy.
Lufuka's educational system is centered around Tonga University, where students from around the world can come to study marine biology and carbon negative production techniques. Holograms are used for visual effects, while 3D printing is used to create physical prototypes for hands-on learning.
The Cube Drone Network provides reliable communications throughout Lufuka. Safety and health monitors integrated in our homes and buildings help to keep our citizens safe and promote a healthy lifestyle. Lufuka has a waste-free mindset. Everything used is biodegradable and recyclable. Our recycling program cleans up the plastic that washes up on our shores and processes it into our watertight biobricks. Removing waste has increased our marine population.
For Lufuka, sea level rising is the existential climate change impact to solve. In the 2020s, the sea level rose 6 millimeters per year, which is double the global average. And now our island is 20% smaller than it was 100 years ago. The sea level rising has had 3 major impacts on Lufuka: coastal destruction, salinization of well water, and increased sensitivity to effects from storms.
In 2014, Tonga created the Tonga Climate Change Trust Fund, which allowed Lufuka to make the technological advancements required to adapt and mitigate sea level rise. An early adaptation was to abandon structures along the coast and rebuild inland. Since this was not sustainable, hydro house technology was developed. Hydro house foundations are platforms comprised of our floating biobricks, composed of biobricks filled with carbon dioxide bubbles. As sea levels rise, our floatable buildings rise too, keeping them safe from flooding.
To adapt to the saltier groundwater, our civil and material engineers develop porous roads and sidewalks over waterproof substructures to collect and funnel rainwater to a storage system capable of holding a year's worth of water supply. We also genetically modified our vanilla and pineapple plants to better withstand salty soil.
To protect Lufuka from storms, civil engineers designed jetties out of biobricks and introduced a mangrove forest behind them. The combined barrier absorbs the impact of storms and tidal waves, and our mangrove forest completely absorbs all impact from wind, protecting our structures and vegetation.
Lufuka has not been responsible for CO2 emissions, yet is most affected by it. Therefore, biobrick technology was developed using raw materials readily available in Lufuka to grow them, taking CO2 out of the air for their production. Biobricks replace much of the concrete used in construction around the world today, reducing the worldwide carbon emission by 5%.
The first step in biobrick production is to grow the special bacteria in our warm tidal water using calcium and seaweed. Sunlight provides the energy for photosynthesis. Hydrodrones, developed by our mechanical and software engineers, fly over the growth to force air with carbon dioxide into the mix, forming a biogoo. Additional drones harvest the biogoo, leaving a small amount behind to continue the growth process. Harvested biogoo is dried and mixed with sand to form a coarse powder, which is our brick starter. The brick starter, mixed with an aggregate and water, either in the factory or on site, makes biobricks after a 2-day cure.
The biobrick lifecycle process was designed by a team of engineers going through the engineering design process, making decisions using trade studies. For example, the natural biological method used in the development of our biobricks minimized cost and environmental impacts. However, for this, we needed an outside farm-like installation that would then be susceptible to weather issues. This led to the development of our mangrove forest to protect the process.
LaFuca has also developed our carbon-free sail freighters to export our biostarter as well as other goods throughout the world. Designed to efficiently capture wind to propel the vessel, these freighters are also covered with solar cells to produce electricity for use in docking or in still winds. LaFuca and other Pacific islands produce and export enough biostarter to currently support 90% of the Earth's building material needs.
LaFuca's adaptation and mitigation innovations to combat rising sea levels has led to the preservation of coastal cities around the globe. LaFuca continues to innovate and challenge the world to address climate change. We know that your nations will benefit from our efforts. Thank you for joining us today. We'd love to answer any of your questions. Yes.
So how did the engineering design process help you create and develop your future city?
Well, our engineering design process helped us make sure we were doing all the right things and making sure we had enough time to organize our model, our essay, and make sure everything was done correctly and in the right process.
To add on what Sarah was saying, the third part of the engineering design process, do, was one of our most challenging parts because we had a lot of ideas, but it was hard to put those ideas onto the model.
Did any of your team's initial goals evolve as you worked on the project?
I think one of our major goals was trying to find a way to make sure the people living in our city would have houses that were able to be danger-free of flooding and rising tides. And that evolved to our hydro houses, which could float on rising sea levels. So there would be no danger of flooding or destruction from the water.
What factors did you consider while laying out the zones in your city? Are the zones separate or mixed up?
So we considered like the natural order of what people would want to do in our zones. So first we laid out our residential zones near the coast because that's where most people would like to live, especially to do fishing jobs. And so we have our mall or our major and commercial building near our citizens so that they can buy whatever they want.
Right here is our city services building where our government is held. The Kingdom of Tonga is a constitutional monarchy, but LaFuca, the city itself, is just a city government. And right here is our educational area where students mostly focus on marine biology and carbon negative design techniques.
What innovative and futuristic technologies is your city using in the production of its power? And how has this reduced or eliminated carbon emissions?
We have three main sources of power in our city. The first one is geothermal, and we extract heat from a volcano 50 miles away. and it's transmitted via superconducting cables. We have hydroelectric energy, which is produced from tidal turbines under the ocean. And each structure in our city has solar cells to produce on-the-spot power.
So what's the mode of transportation? I don't think I've seen that, or maybe you have explained, I missed it.
So the main form of transportation throughout our own city is just walking or biking. It's supposed to be a walkable city, which means that it's not supposed to be designed around cars, but more instead designed around people going where they want to on foot. But to travel outside of Lafuka, we have these underwater bullet trains, which can travel to New Zealand or Hawaii, which both have airports to take you wherever you want.
One of our modes of transportation for emergency services is the E-Quick Speed, which is drones that can detect, and they have sensors built into them, and they can detect if anybody needs help. So, and we also provide our citizens watches. So if they need help, it alerts the E-Quick Speed, which has humans in them. And the purpose of it is that they're flying, so there's nothing like blocking them.
So what do the people of Lafuka do for fun?
We have our underwater park system. We have 5 parks on our model right now. Each represent a different thing. There's a sports center, there's a park for the elderly, there's a park for the disabled, and there's a park for elementary school kids. And that is one of the main sources of recreational fun for our city.
Yes, citizens can use our elevator, our like water elevator, to get down to the parks.
I'm interested in the one for the elderly. Tell me about that.
Okay.
So like all of our parks are specifically designed to like help certain people who have issues. So the elderly who could have difficulties walking or anything like that, and maybe in wheelchairs, we provide lots of different ways to have fun in our parks, not like running around. And we also have ramps and make sure that anybody who has any disability is able to travel anywhere.
So you have a volcano right next to your island, right? What happens if it just erupts?
So we have a facility surrounding the volcano to measure like a volcanic eruption and to make sure that it doesn't happen. And if we can't sufficiently prevent it, we have defense systems to essentially keep all of the eruptions centralized so that it doesn't hurt the environment or our city.
I don't think you can control the volcanic eruptions. But it'll be nice to, if you have a way to do it. I don't think it's possible.
So that is a good point. Certain levels of volcanic eruptions we cannot contain because they're just too strong, but lower level volcanic eruptions we are able to contain properly.
So I know you're part of the Kingdom of Tonga, and you explained that they're a constitutional monarchy, but you also said that you had sort of it sound like an somewhat autonomous government. So could you talk about that? Like, who's in charge of that? Do you make your own laws, or you sort of do what Tonga tells you to do? How's that work?
Well,
Yes.
okay, sorry. Well, right here is our city services building. And really the point of Lafuka is that we want to help the people. And in order to help the people, we need to get all of the ideas from every citizen of Lafuka. And we listen to the laws that are built in from Tonga, but we also have like engineering codes for our houses. And like as I mentioned before, when I was talking about these hydro houses, a code is that if they're within 200 meters of the coast, they have to be built on these hydro houses.
So what type of grading system you have for your education?
Sorry. So we actually provide great teaching for grades pre-K all the way to college level. This is our biggest structure, and the middle school and all elementary.
So next up, we have St. Andrews Drexel Hill.
Wow, Dustin, is this Tokyo? With a population of over 14 million and rich in culture and tradition, citizens and tourists alike enjoy MyCal performances and its famous cherry blossom festivals. But why does it look like it could use some improvements?
Well, much of Tokyo and Tokyo Port are in low-lying areas, which are prone to flooding.
Looks like they built these massive seawalls to help, but they're hard and cold. Citizens complain and say it feels like they live in a prison. This place is worse than the Upside Down, but how'd it get this bad?
Well, the most pressing reason is climate change, resulting from stuff like greenhouse gases and carbon emissions.
How are greenhouse gases emitted?
They're emitted by manufacturing, transportation, and improper disposal of waste. When carbon dioxide is released into the atmosphere, it traps heat from the sun, causing climate change issues we're facing today, like severe storm surges and rising sea levels.
That's awful. I wish we could enter into a new reality where all our problems were solved.
I can help. I can take you to the future.
Whoa, hi, Levin. Can you really do that?
Yes, just watch. This is Keizan Serita Tokyo in 2123, translated as Improved Tokyo. Government officials have implemented many measures to adapt to climate change while improving the quality of life for citizens. They have introduced many ways to mitigate climate change with the goal of eliminating greenhouse gas from the atmosphere and stopping future emissions.
That's rad.
This underground floodwater cathedral was built back in 2006 as an adaptation measure, but has been improved in the future to use diverted floodwater more efficiently. Collected water is desalinated, purified, and treated. Potable water is then pumped throughout the city. The brine byproduct is used to manufacture de-icing salts, a major export and source of revenue for Improved Tokyo.
And check this out. There is now a 7-mile-long, multi-purpose, retractable seawall to protect Tokyo Bay. Designed by civil and structural engineers, this new seawall nests in itself, allowing ships and marine life to pass through uninhibited until needed for protection from storm surges. Electrical engineers have developed storm surge sensors, which detect rising water, triggering movement of the wall.
The wall also contains piezoelectric crystals, which convert wave vibrations into usable, clean energy. It's eco-friendly, innovative, and effective.
An obvious trade-off of the wall is the effect that it could have on marine life, but they work with marine biologists and environmental engineers to ensure minimal risk for sea life.
The seawall isn't the only adaptation measure put in place. Floodgates float when the cavity below fills with water. It rises up as water levels increase using hydrostatic pressure with no power required.
Despite all these adaptation measures, citizens have still made some adjustments to their lives to adapt to climate change. From FC Tokyo matches to sumo wrestling, Japanese tradition runs deep. Many stadiums, schools, parks, and restaurants have been raised above the flood zone with access provided from raised transportation as a precaution.
Adaptation is shown in architecture too. Homes are built with sealants and windows, flood barricades at doors, and individual gardens. Additionally, Keizan Serita Tokyo has replaced all grade level farming with vertical hydroponic farms and greenhouses throughout the city. Citizens are safe and the risk of food disruption is eliminated.
Another adaptation measure is K-bands, which was designed by computer engineers. K-bands alert the user when storm surges are nearby, so shelter can be reached well in advance. They also detect abnormalities in blood pressure and breathing, so medical personnel can be reached in an emergency.
And if all else fails, submersible and submarine rescue drones are designed specifically for these situations. They can be deployed immediately using thermal seeking technology to find and locate victims. They can hold up to 500 pounds and are able to perform CPR.
Great adaptation measures, but how are they mitigating the effects of climate change?
The way to mitigate climate change is to reduce the amount of greenhouse gas in the atmosphere. For this, DAX mitigation was invented. DAX stands for Direct Air Capture and Storage, and Keizan Serita Tokyo has hundreds of DAX throughout the city.
DAX are massive fans that draw in air passing through filters, trapping carbon. The carbon is then combined with hydrogen to create hydrocarbons,
a clean fuel source that did not require the burning of fossil fuels. Unfortunately, a trade-off for DACs is the cost of the installation and the amount of energy needed for them to operate.
I know a little something about mitigation too. It's called photosynthesis. Not only does all this greenery beautify the city and those ugly seawalls, but it effectively removes CO2 from the atmosphere and replaces it with oxygen. This improves quality of life while decreasing the amount of carbon in the atmosphere through carbon capture.
But what about mitigation through prevention?
Energy production and transportation. These two industries are responsible for over 50% of greenhouse gas emissions, but not in the future. Geothermal energy plants use the natural heat from the earth to generate electricity, while several solar power plants are located throughout the city. Combined with the PV electric seawall and roads, all energy production here is clean and renewable, producing no carbon output into the atmosphere.
And how about transportation?
Motor vehicles run on converted hydrocarbons and maglev trains run on electricity, so no carbon emissions. Improved Tokyo has two major train runs, the goods transportation system and the public transportation system.
Hey, 11, I like this new Tokyo you created with your magic.
It's not magic, it's the engineering process. Identify the problem of climate change, learn the specifics. Climate change leads to severe weather, which leads to more flooding.
Design adaptations and mitigations, build seawalls, floodgates, and DAC systems.
Build mockups and models, test, improve, and redesign all systems until satisfied.
And the final step, share improved Tokyo with its citizens. I hope you guys learned something. And I'll see you on the flip side, if you get what I mean.
Yeah, so how did the engineering design process help you create and develop your future city?
So with our engineering process, we had one idea, and for example, we wanted our trains to move, but we learned very quickly that that's very hard to do. So we had multiple different test runs, and we learned quickly that sometimes ideas don't work out.
Another idea that didn't work out was our floodgate. We tried using real water, but because the scale was so small, the water kept on leaking through. So we had to adapt and use fake water.
So how did your team's initial goals evolve as you worked through the project?
So our original goal was to create a carbon-free city. But then that goal kind of evolved, and we kind of also built into somewhat of a circular economy with our piezoelectric roads. The roads power the car and the car powered the roads.
So we wanted to show that we want to use the floodwater as much ways as we can. So that's how we came up with, we've repurposed already like floodwater cathedral to use it in our wet fire systems with sprinklers. And it's water that's used throughout the daily lives of our citizens in Tokyo.
And with our DAC systems, the original intent was to remove carbon from the atmosphere, but as stated before in the skit, the hydrocarbons can also be used to power the cars and buses and other things.
Another way was the brine used that was taken out of the underwater cathedral. We also turned that into de-icing salt over here. And it's another source of revenue for improved Tokyo.
Very good, yeah. What factors did you consider while laying out the zones in your city? Are these zones separate or mixed use?
Okay, so when mapping out our zones, we wanted to think about how reasonable it would be during the lives of our citizens. So our commercial zones and our residential zones are very mixed. So our commercial buildings are blue and our residential buildings are white. So as you can see, a lot of them are close together. But with our industrial zone, we know we wanted to keep that further away from our citizens. So we have our industrial zone kind of squared off on our model, but to show that we wanted to show on our board, but it's actually a few miles outside of the city. And a lot of it is mixed use.
What innovative and futuristic technologies is your city using in the production of its power? And how has this reduced or eliminated carbon emissions?
So, okay. So one is our seawall. So we mentioned in the presentation that with the piezoelectric, all right, let me show the seawall, that the piezoelectric crystals in the seawall actually power the storm surge sensors, which, yeah. So the piezoelectric crystals power the storm surge sensors. So when the water pressure changes, it sends a signal to the hydraulic pistons, which would trigger movement of the wall.
Another way that we found a new power source was through the DAC system, which, as we stated in the skit, it not only takes carbon out of the air, it then combines that carbon with hydrogen, which creates another fuel source, so more carbon is not emitted.
Yeah, so how easy or hard is it to take carbon and get it, to combine with hydrogen, right? You're looking at hydrocarbons. How hard or easy is the process? Let me put it another way. Is it energy? Do you need more energy to convert the carbon dioxide into hydrocarbons, or?
So yes, so that's where our part of our solar power energy comes from. So we have many different solar power plants throughout the city, and even we have some on our residential buildings. So when we have to mix carbon and hydrogen together, we do use that like free energy from our solar panels.
So lots of technology here, which is great, but what do your people do for fun?
So
go ahead.
So over here we have an FC Tokyo football stadium. And so we also have a sumo dome over here. And we have with a entertainment center below it. And we have a park over here where the Cherry Blossom Festival is held.
To speak more on the Cherry Blossom Festivals, so it's kind of hidden, but that's a big part of Tokyo. So we wanted to make sure that it was shown on our model, and that to show that people in Tokyo and citizens, they love cherry blossom tree festivals and the art. But also we have a museum here, which is a broken down Rubik's Cube. We have casinos, an art studio, we have malls, we have movie theaters, we have different shops, and we have a toy store. So
Yeah, Tokyo is known for using nuclear energy. What type of energy did you say the main is it solar or?
It is solar.
It is solar.
It's not only solar, we also use other ways.
we use solar and geothermal energy.
And piezoelectric.
Tell me a little bit about the governance of your city. Who's in charge? Who runs it? Who makes the laws? How does that work?
So
Go ahead, Mason.
So we have a parliamentary government.
Yeah, so the Japanese government, so they have two houses of government, and then it is all run by the prime minister, and then similar to what we have in America is that in Tokyo specifically, they do have a mayor, which focuses on stuff at the more local level.
Finances. I said before, there's like 9 people running for mayor in Philadelphia. And at some point, they're going to have to talk to the people about taxes. So tell me, it's important. How is your city financed? How do you raise the revenue that you need to do all the great stuff that you're doing?
All right, so one of our sources of revenue other than taxes are the K-bands. So they are free to citizens, but they are also sold overseas into other countries, which is a source of revenue for New Tokyo.
Since Tokyo has such a large population of just about 14 million, you don't really have to raise the taxes that much to get a lot more revenue. So raising taxes isn't really an issue.